Hello everyone, in today's video we will perform the experiment on Bernoulli's theorem. Aim of the experiment is to verify the Bernoulli's theorem. Firstly, we will see the statement of the theorem. Bernoulli states that in a steady, ideal flow of an incompressible fluid, the total energy at any point of the fluid is constant. That total energy is represented in the three forms. First one is due to the pressure energy, second one due to the velocity which we call as an kinetic energy, and third one is the potential energy. So sum of these three energies is nothing but the total energy. These three energies can be represented in the form of head, that is meters of water. In equation 1, v1 square upon 2g is nothing but it is the velocity head which is due to kinetic energy at section 1. P1 upon gamma is nothing but it is pressure head which is corresponding to the pressure energy. And Z1 is nothing but it is the elevation head which is corresponding to the section 1. In the same manner, to the right of the equation, v2 square upon 2g plus p2 upon gamma plus z2 is nothing but the total energy at section 2. So equation 1 represents the total energy at section 1 and section 2 respectively, which is constant. Now we will see components of the Bernoulli's apparatus. This is the complete setup of Bernoulli's apparatus. The first component is measuring tank, which is white in color. The next component is supply tank, which is grey in color, and there is a controlling valve attached to the pump. To pump there is an inlet pipe which is attached to the inlet tank, white in color. Inlet tank is attached to a pipe, or you can say a conduit. To this conduit there are piezometers, 14 in numbers, which is attached to outlet tank, and there is an outlet valve to the outlet tank, and there is a gate valve to the measuring tank to control the flow through the measuring tank. Now we will start the pump, and with the help of controlling valve we will allow the water to flow from the inlet pipe. Here green color pipe is nothing but inlet pipe which is attached to the inlet tank. Through inlet tank water will flow through the conduit, and we can see there is rise in water level in each piezometer. This rise in water level is due to the controlling valve. As we are controlling the valve, that's why there are fluctuations in each piezometer. Now we have to make these fluctuations at steady state. Steady state is nothing but with change of time there will be constant level of water in each piezometer. So to make this state as steady, we will stop the controlling valve. Now you can observe in each piezometer there is a constant level of water. So now we will note down the value of each piezometer as P upon gamma. For piezometer 1 it is P1 upon gamma. Now we will release the outlet valve. After releasing the outlet valve, the water will come into the measuring tank. Through this measuring tank, we will be finding out the discharge through the tank. Now we will start filling the tank, and we will note down the rise in 10 centimeter of water into the tank and the time required to fill this 10 centimeter of the water. So as we can see the formula, discharge is nothing but it is volume of water collected into the tank upon time required to collect water in the tank. Therefore volume is nothing but area of tank into rise of water level. So in our case rise of water level is 10 centimeter. So now we will stop the stopwatch or the timer at 10 centimeter. So in the tube we can observe there is a 10 centimeter level of water. So at this stage we have stopped the stopwatch. So in this way we can calculate the discharge. Now we will release the gate valve. to evacuate the measuring tank. So this complete is nothing but one reading. So now next is measurement of the velocity. After knowing the actual discharge, we can find the respective velocity for all the piezometers. As we are having 14 piezometers, so we will be treating those piezometers as 14 different sections. So at section 1, that is piezometer 1, there will be the velocity V1, which is nothing but Q upon A1. A1 is nothing but it is the area at section 1. Now we will find out the velocity head, which is nothing but V square upon 2G. And lastly, total energy, which is the summation of pressure head, that is P upon gamma, plus velocity head V square upon 2G. So in the observation table we can see now, first column is serial number 1, second column is piezometer number. So we are having 14 piezometers, we will note down those numbers 1, 2, 3 up to 14. The third column is rise of water level in piezometer. So this will be the reading when we have stopped the controlled valve and the level of water in each piezometer were constant. So that will be treated as the rise of water level in piezometer, that is P upon gamma. Now next is cross sectional area. So corresponding to the piezometer number 1, there will be the area A1. So this area is nothing but area of the conduit at respective section. For piezometer 1, area at section 1, area of the conduit at section 1. For piezometer 2, area of conduit at section 2, and so on. Now we will determine the section velocity at respective section, that is respective piezometer 1 to piezometer 14. So the velocity will be with the help of formula as we have seen, V is equal to Q upon area. So there will be V1, V2, V3 up to V14. And lastly, we can have the velocity head, that is V square upon 2G at respective sections. And we will sum up all the heads, that is pressure head and velocity head. That will give us the total energy value. Lastly, we will draw a graph to obtain the total energy line and hydraulic gradient line. Total energy line is nothing but it is the line joining the points of all the energy heads. In our case, we are having two energies, that is pressure energy and velocity energy, which is obtained in our observation table at the last column. So those points we have to draw for the respective locations. On the x-axis, we have represented the distance between each piezometer, which is at a distance of 5 cm each. And on y-axis, there is an energy level. So after knowing the minimum and maximum value of the last column in observation table, we can have the marking on the y-axis. So now we will plot the total energy values on the graph paper, and we will join all the plotted points with a smooth curve. That curve is nothing but the total energy line, which is in blue color. And next one is the hydraulic gradient line. So from the observation table, the third column is nothing but the rise of water level, which is nothing but ultimately it is the pressure head, that is P upon gamma. So those points we will plot on the graph. We will plot all points of P upon gamma for the different locations, and we will join those points with the smooth curve. That line will represent the hydraulic gradient line, which is in orange color.